In this video, we're going to go over how to solve an inequality and how to graph the solution on a number line. The first two examples are going to be more middle school level math, and then we're going to kind of jump into high school level inequalities. You solve these just like you would an equation. So if I'm looking at number one, I need to get x alone. So I'm going to add the 8 first. And I'm just going to leave my symbol alone. Now I have 3x is greater than or equal to 21. And then I still need to get x alone. I'm going to do this the same way as if it was an equal sign. I'm going to divide by 3 on both sides. And then I get x is greater than or equal to 7. Now when we go to put this on a number line, ignore my sloppy line, I'm just going to plop 7 down here. You can continue your number line if that makes you happy. And then what you need to know is that if you have the or equal to symbol underneath the greater than or underneath the less than, this means 7 is included. So we graph it with a closed circle. If it was not or equal to, we would have an open circle. And then I'm going greater than, so that's everything to the right. So notice that your graph matches the direction of the symbol. All right, let's do another one. Number 2, this one's a little bit harder. Still kind of in middle school math land though. I'm going to start by getting rid of the 5 because it's not attached to the x, so I'm going to subtract 5 from both sides. This leaves me with negative 3x is greater than negative 15. I now need to divide by negative 3. When we divide by a negative in inequalities, we have to flip the symbol because it makes it opposite. And so this is going to become x is less than. So I went from greater than to less than. You flip the symbol around when dividing by a negative. And negative 15 divided by negative 3 is positive 5. So now I'm going to graph this on a number line. I'm going to plop 5 down. I'm going to use an open circle. And again, you can make this better if you'd like to. I'm going to use an open circle, and I'm going to be pointing to the left this time because it's less than. And my symbol and my arrow point the same direction. I also used an open circle because it wasn't or equal to, meaning 5 could not be included. All right, now we're getting a little bit more high school-y. This is still a bit middle school level inequality, but it might not be fresh on everyone's mind. I'm going to start by getting my variables to one side. I personally always move smaller variables so that I don't end up with a negative and have to flip my symbol. So I'm going to subtract the 5x because it's smaller. And then when I do 9x take away 5x, I'll be left with a positive 4x. If you had gone the other way, you would have been left with negative, and then you would have to remember to flip your symbol. I'm then going to add this 5 to both sides. That leaves me with less than or equal to negative 1. I do not need to flip my symbol because I'm not going to divide by a negative. So multiplying and dividing by a negative is the only time that we flip our symbol. I'm going to divide by 4, and now I'm left with x is less than or equal to negative 1/4. So I'm going to draw a number line. I'm going to be lazy and just put my negative 1/4 here. And then I'm going to use a closed circle because it does include the line underneath the symbol. It's less than or equal to. And then I'm pointing it to the left because it's less than. And on a number line, all smaller numbers are to the left. All right, number 4. Now we are officially in high school math land. There's a lot going on here. So we need to remember the order of things to do when solving an equation. The first thing I'm going to do is distribute this negative 3 in. So I'm going to drop down my 6x because it's not being impacted by that negative 3. Negative 3 times 4x is negative 12x. Negative 3 times 1 is negative 3. And then I'm going to drop everything down. You could do more in one step, but I'm just going to do one thing at a time. I'm now going to combine like terms. I see that 6x and negative 12x are on the same side. They're like terms, they can be combined. Also, 10x and negative 7x are on the same side, and they are like terms, they can be combined. 6x take away 12x is negative 6x. Sorry about the zooming. Then I have minus 3, drop down my less than. 10x take away 7x is 3x, drop down my minus 8. We're now in that spot where if you're strategic, you won't have a negative in front of the x when you go to divide. Let's say you forget to be strategic. And so if I was being strategic, I would add 6x to both sides, and that would leave my x's positive. Let's say instead, you decided to subtract 3x. I'm going to show you what we have to be careful of. So this would give us negative 9x minus 3 less than negative 8, because that canceled out. I dropped down this negative 3. I dropped down that negative 8. And the only thing I did was I changed negative 6x, take away 3x to negative 9x. I'm going to add the 3 to both sides. I now have negative 9x is less than negative 5. And so when I go to get x by itself, I'm going to divide by negative 9. I've run out of space. And I've got to flip to greater than because I'm dividing by a negative. So I'm going to flip to greater than, and I'm going to make this positive 5/9. And then on my number line, I would have 5/9. It would be open circle because it's not or equal to, and it would point to the right because it's greater than. Also, the symbol and the arrow point the same direction. Something I think valuable to point out. Let's say we were at this step right here. I'm just going to draw this out over here again. Negative 6x minus 3 less than 3x minus 8. Okay, let's just say we're here, and I'm going to solve it a different way. I'm going to show you how it's the same thing. Let's say I go to solve this, and I had added the 6x, because that's normally what I would do. So now I have negative 3 is less than 9x minus 8. So if I'm here, I need to get x alone. I would add this 8 over. That would give me 5 less than 9x. When I go to divide by this 9, it's going to look like I have 5/9 is less than x. I want you to understand that x is greater than 5/9 is the same thing as 5/9 is less than x. It's like you just flipped the whole thing around, but it's still opening towards x and still pointing towards 5/9. So those two things are the same. Okay, let's look at this last problem. Another very high school level inequality. I'm going to start by distributing. I'm going to drop down this negative 5. I'm going to drop down this 1, and I'm going to distribute the 3/2 in. Now, you can use a calculator, but the way I would do this without one is I would go ahead and do 4 divided by 2. So negative 4 divided by 2 would be negative 2, and negative 2 times 3 would actually give me a negative 6x. Another way to do that would be to do 3 times negative 4 is negative 12, divided by 2 is negative 6. Then I'm going to take this 3/2 times the 6. So again, if I do that, you can do the 3 times 6 first. That would be 18. 18 divided by 2 is 9. And then I'm going to combine my 1 and my 9. So I have negative 6x plus 10. I am going to take take 10 away from both sides. And I have negative 15 is greater than negative 6x. I'm then going to divide by a negative. We were not able to avoid that. So when I do, this is going to change to less than. Now remember, x is on that side. We're going to talk about how to rewrite it so we can draw out our number line. 15/6 can be reduced. They're both divisible by 3. So this would be 5/2 or 2.5. When I go to put this on my number line, this is the same as x is greater than 5/2. The symbol is still opening on the side pointing towards x. All right, now I'm going to draw a number line. I've got 5/2. I need it to be open, and I'm drawing it to the right. So that is how we solve and graph inequalities.